Welcome to this presentation by Exact Education. The purpose of this video is to explain the shape of a catenary and how to implement the equations into Excel so that we can plot the U shape of a catenary. The shape of a heavy cable or chain fixed at identical points hanging under its own weight is called a catenary. So a catenary is a hanging cable acted upon by its own weight, suspended only at its ends. The cable forms a U-like shape. Mathematically, it is a hyperbolic cosine in the form of equation y, which is the height equals c times COSH of x divided by c. The c value determines the width of the catenary and its lowest point above the ground. Cables with larger values of c will have less sag. A catenary is the shape of a chain that supports its own weight, and it's said to be strictly in tension. If we invert the catenary, we get the shape of an archway, which is an inverted catenary that supports only its own weight, is strictly in compression, which is the opposite of tension. This arch shape is ideal in the sense that the arch experiences no shear forces. If we look at our Excel, what we've got on the left-hand column is a table of various distances we want to have between our fixing points. We have the next column here is a table of various x values. So that is the horizontal distance either side of the lowest point. And then we've got our third column here, which is the calculated height required to fix the endpoints so that the cable hangs under its own weight to meet the specific distance between the endpoints and the minimum clearance above the ground. The equation that defines that is the vertical height is c times hyperbolic cosine brackets x divided by c, where x is the half the distance between the fixing points. The equation has been set up to take into account the defining the distance between the fixing points and the minimum clearance. So for example, what we have there plotted out is we've got a distance between fixing points of 20 meters and a minimum clearance of 3. And we can go in and change these values and we can see that the graph changes. If you want a minimum fixing point of 3 meters and say we want a distance of 16 meters between the fixing points, we change those values there. Those values are picked up in the equation here in the Excel, and we plot out our catenary shape in Excel, and we can see the fixing points here are identical, 16 meters apart, and that's shown by the horizontal distance here, plus or minus 8. We have a minimum distance here of 3 meters above the ground, and our required height, our fixing point height, comes out to be 21.69 meters. If we, for example, only want a distance of, say, 13 meters, what we can do is change that value to 13, and that's picked up in the calculations. What we can see here is the distance between the fixing points is 13, and we get an almost identical fixing height of 13.27. However, if we look at our plot, it is not balanced on the screen. So what we have to do manually, we start here at 30 meters, we're starting then at plus 6.5 meters in the positive x direction. What we need to adjust is take out these values from the recommended chart by taking those values out manually here so that we balance it up, and then the graph will adjust itself so that it's got identical fixing points. And what we can see is we're putting the requirements. We want a minimum 3 meters clearance above the ground, and we want 30 meters between the fixing points, and the required fixing height then comes out to be 13.27 meters. And if we look at our Excel plot here, what we can see is the distance between these fixing points here is 30 meters, and the required height is 13.27, so they're almost identical. Thank you for watching the explanation of catenary, hyperbolic, cosine, and how to plot that out on an Excel spreadsheet. Thank you.